Good afternoon, everyone, and welcome back to Designing for the Desert. Every Sunday at 2 p.m. Dubai time, we explore what it truly means to design responsibly in arid regions, not just aesthetically, but technically, operationally, and strategically. Today's session is slightly different and very important. We often talk about climate response, materials and shading strategies, and sustainability metrics. But behind every successful desert project lies something deeper: design coordination. Because in hot, high pressure environments like the GCC, projects don't fail due to lack of ambition, they struggle at the interfaces between architecture and structure, between MEP and facade, between sustainability intent and operational reality. And today's speaker understands those interfaces better than most people. Mustafa Saber is a design manager with over 2 decades of experience across architecture, engineering, BIM implementation, and large scale development coordination across the UAE and KSA. He has worked across the full project lifecycle from concept through IFC, managing multidisciplinary teams, leading BIM transformation strategies, and resolving complex design conflicts under demanding timelines. What I appreciate most about Mustafa's approach, and you'll see this in his presentation, is that he doesn't romanticize sustainability. He brings it back to reality, to responsibility, authority, testing, integration. So today he'll be walking us through how complexity really emerges in desert projects, how climate affects design making at every level, and how performance is determined not by isolated design intent, but by integration across systems. So, Mustafa, the floor is yours.
Thank you, Odit. Appreciate the introduction and happy to be here with you today. Let me start today my presentation with a quick introduction. So, a quick introduction about myself, not as a CV or a resume, but to put things in perspective behind this talk and how I prepared it. So, as you mentioned, I have 20 years of experience across architecture, engineering, and BIM and design management. I've done this across both sides, consultant and as a design manager for developers as well. So this brings a different perspective to my experience because I've seen how it works when the risks do not match or the assumptions do not hold. Most of my work have been in hot regions, in Egypt and in Saudi Arabia, and as well in the UAE. And I focus on the delivery of projects with efficiency as much as possible, under pressure, of course, and sometimes sustainability when it's a metric that is required for the project is also applied properly with coordination between other teams. So what I'm sharing today is not going to be theory, I suppose, and hopefully give more insight to people who haven't worked in these environments before or did not have the chance to work on sustainability projects. Let me start with a moment that many in our industry might remember. During a major New Year's Eve celebration in a major city that I'm sure people will recognize, while attention was all on the fireworks nearby, a high rise building caught fire. The fire quickly spread along the facade, and within minutes, it became global news. Thankfully, there were no casualties. Emergency response worked exceptionally well, but something important came out of that incident. It highlighted that emergency vehicle access above podium in this development was not well studied. And this is an issue of coordination. Sometimes it happens due to rush, sometimes it happens due to oversight. And it's common in our buildings that we do our ideas, we do our designs, and we think that all the assumptions have been made and everything has been cleared, maybe even according to code, but sometimes something is missing. What that incident reminded many of us is this: projects rarely struggle because of one discipline has failed. More often, challenges happen at the interfaces between architecture and civil planning, between facade design and environmental performance, between sustainability intentions and operational realities. And in hot climate and arid regions like ours, those interfaces become more sensitive. Heat, solar exposure, water scarcity, and operational pressure reduces the margin for assumptions. So design complexity isn't really about more information to be provided. It's about better integration between these systems. One thing I always emphasize is that sustainability isn't universal. Although there are many codes that talk about sustainability which are universal, there are always criteria that are specific for specific climates. Strategies that work beautifully in cold or rainy climates can actually create problems in arid regions. In colder climates, for example, buildings like the one you see on the left side, which is a building in Canada, are often designed to capture solar heat, retain warmth, and manage moisture. Glass facades might be intentionally designed to absorb solar gain and to reduce heat demand. But in arid climates, we're doing exactly the opposite. We're trying to reject the solar heat as much as possible, control the solar exposure, reduce cooling loads, and manage scarce water resources. So sustainability isn't a checklist. It's a response to environment. It's something that you design based on that climate you're designing for. And when that response is not aligned with climate, complexity increases instead of decreasing. To the right side, as you can see, this building, Al Bahar in Abu Dhabi, is a building that has been designed in response to the hot climate that we live in. One thing I've seen across projects is this: when sustainability is treated as a core design driver from the beginning, it simplifies many decisions later, not as a byproduct of a side idea or a side metric or a requirement. It's more of a design driver. So in these cases, some of these developments will do this very well, where environmental performance, orientation, infrastructure, and urban planning are all aligned and considered from day one. And the difference is usually visible in the end results. Because real sustainability starts at concept stage, when building orientation is still flexible. You can still change the location of the building, and the massing decisions are still open. The infrastructure loads are still manageable. Maybe you can still negotiate it or change it or add to it. If sustainability enters late, it doesn't fail, but it usually requires adjustments, compromises, or additional cost to achieve it. Early integration, on the other hand, tends to make projects more coherent and easier to deliver. One dynamic we all experience in projects is tension between speed and understanding. Developers, on one hand, as I have seen, naturally focus on timelines, return on investments, and keeping momentum of the progress going on. However, design teams require time, on the other hand, to study options, coordinate disciplines, test assumptions, and understand long term implications. And this is not only about sustainability, it's more about every design decision that we make. It applies to everything from planning facade strategies, infrastructure, structural coordination, and operational performance. When decisions move faster than the understanding of the team, complexity will not disappear. It simply moves downstream to later design stages. And that often shows up later in redesign issues, operational inefficiencies, or performance gaps. The best projects do not eliminate this tension between these two different requirements, but they manage it consciously. Earlier, I mentioned that complexity often lives in the interfaces. This is where it becomes practical between disciplines. If you look at the disciplines of architecture, structure, MAP, ID, landscape, infrastructure, all these disciplines, sometimes assumptions are not the same between teams. And these interfaces are also found between project stages. So, what the team has been considering during concept design might not hold true due to additional information being displayed on the table at schematic stage or at technical detailing or at IFC package. So, these information and interfaces also happen during the transitions between these stages, different stages. This also happens between responsibility and authority, where someone owns the risk, but someone else controls the decision. And this is where assumptions accumulate. And in arid environments, those assumptions tend to surface quickly because performance margins are smaller. Once complexity appears in the interfaces, the next question becomes performance. How does my building perform? How do I make it perform better? Because good individual design decisions do not automatically create good overall performance. A well designed facade alone won't ensure thermal comfort. Efficient system alone won't guarantee operational efficiency. And sustainability targets alone cannot guarantee real environment performance. It is an integration between all disciplines and operations that determines how a building actually behaves. Each responsible team member must perform his role within the overall vision, considering that they all fully understand it for this vision to come really true. Most design complexity isn't easily visible in drawings. It shows up when systems meet reality, climate users, operations, maintenance. I mean, this is why you actually see many spaces and buildings being repurposed or transformed after the building have been completed. Sometimes the design assumptions do not hold true for the operation teams. So they think this space is not working for us. Let's repurpose it. Let's change it. And this is where the interfaces are not working really well. The interface between the operation team, the end users, and the designing team who started with wrong assumptions. Once we talk about integration and performance, the next logical question becomes what environmental forces are we actually integrating against? Usually, in hot environments, the biggest issue or the biggest assumption that we want to counter is going to be integrating against solar exposure. And this brings us something really fundamental, which is the solar path. I've seen in many cases, some of the architects are not considering solar path properly in their design. To the left, you can see the solar path of Dubai as an example. And to the right side, you see how this affects, how this arc of the solar path moves in 3D dimension. And this sun path determines how much heat the building is going to receive. When they receive it, during winter, during summer, early in the morning or afternoons, and which surfaces are most affected. Because the sun is high for most of the year, the horizontal surfaces, especially roofs, often receive the largest share of heat gain. The walls follow, and then the glazing according to your design and to the orientation of your building. So, before we start discussing materials or systems, teams should really focus on the design of the building itself, how it behaves in real scenarios under the solar heat. The orientation is really important, and it can magnify or change your design decisions at early stages. Let's take this project as an example. This is a project that I experienced working with ex-architects, a previous employer I worked with. This is Antara Museum. It's a cultural project that was inspired by Antara bin Shaddad. He is a historic figure for being a poet and a knight as well. And the design approach was intentionally to link it to the context, to the site that we are designing for. Rather than placing a dominant building mass on the site, the project was conceived almost as a geological intervention. It looks like a crack in the terrain, revealing just an entrance. So if I go here, you can see the entrance only pops out of the ground, and this is the only thing that you see. It's a solid entrance, very intriguing for the users and for the visitors to want to know what's behind this solid entrance. Of course, with that design, it reduced the direct solar exposure significantly, stabilized the internal temperatures, and allowed the architecture to remain respectful to the historical context we're designing for. Only selected openings allowed controlled daylight in this design, minimizing heat gain while maintaining spatial quality. For me, this project illustrates something important. When design responds to climate and context early on, sustainability becomes a natural outcome rather than an added layer. To contrast the previous example, I wanted to share this other example with you. This is another high performance driven project that I worked with and I was involved with. The Sustainable City on Yas Island. It's a project that happened as a collaboration between Diamond Developers and Aldar. And this project focused heavily on measurable sustainable outcomes: envelope performance, solar integration, energy efficiency, shading strategies, and self shading for buildings, and even digital performance monitoring were all considered from day one because the vision was clear early on. The development achieved the highest Istidama Pearl 5 for a housing community. And this was the first time a housing community gets 5 Pearl for Istidama in Abu Dhabi. This is the sustainability metric that is being used in that region. It also received multiple recognitions related to sustainability performance and digital integration. For me, the key takeaway is this: when sustainability becomes a design driver early in this project, as an example, not an afterthought, it aligns architecture, engineering, master planning, infrastructure, and even operations towards a shared performance goal. This contrast between these two projects shows two different expressions of sustainability. One responds deeply to cultural context and landscape, the other is focusing on measurable environmental performance at an urban scale. But underneath, the same logic applies. While you only see architecture on the surface, below this, there are many early decisions that have been taken: orientation, integration, and envelope strategy. Infrastructure planning shaped long term performance. The visible architecture is only the surface. Most sustainability impact happens in decisions people rarely see. When we understand climate response, the next practical question is simple. Where does most heat actually enter buildings? And heat usually enters most of it, 50 to 70% is actually entering the building through its roof. So this is our biggest concern for any designer who wants to design in this region. The walls come next, depending on orientation and insulation, the quality of insulation and the continuity of this insulation, avoiding thermal bridges in very small areas that people might not see. The connection, for example, between windows and walls, between the uh, insulated blockwork or the insulated precast panels and the roof. These connections usually work as thermal bridges, and this is where the failure of the system or the reduction in quality of insulation actually appears. So, sustainability often starts with very basic decisions: roof insulation, wall design, glazing ratio, shading strategy. These are the basics that we start from, and then we start looking at the interfaces between these elements of a building. So, after looking at climate response, real projects, and envelope performance, I like to simplify decision making into practical filter I personally use. I like to call it the rat test. Before phrasing any decision, I ask three simple questions. First, responsibility. Who carries the responsibility of consequences if this decision malfunctions or underperforms? For example, increasing the glazing area. This may improve the views and improve marketability of a project, but operations team often carry the long-term energy cost and the comfort complaints from the end users. So clarity on responsibility matters early. Second is authority. Who actually has the power to decide across all disciplines? We've all seen situations where engineers recommend better insulation or shading, but cost decisions override performance goals. So responsibility is really important with authority. You cannot give responsibility to someone without giving them authority over other aspects of the project. And third is testing. Has this issue or has this method been tested before in reality? Is there a mock-up that we should ask for? Is there something that we can do? Has this been commissioned before? Is there an operational feedback? And working at a developer really gives us this edge because we understand what went wrong and what was acceptable in terms of operation on long term for developments that have been built 10 years ago or 15 years ago. You can see how your building actually performs in reality. Even good facade designs, for example, can underperform if installation, quality, or detailing isn't properly tested. In my experience, when responsibility, authority, and testing align, sustainability and performance tend to follow naturally. I'll close this with one practical reflection. In real projects, sustainability isn't just about intent. It has to align to how the client plans to operate the building. Will they manage it directly or outsource operations? Are there electrical capacity constraints, cooling load limitations that we're not aware of, maintenance capabilities that doesn't exist? These realities often shape what actually works more than theoretical performance targets. So, sustainable design isn't only about responding to climate, it's about aligning climate response with operational reality. When these elements do not align, buildings spend years compensating for the wrong assumptions, technically, financially, and operationally. So, design with climate, align with operations, and always test in reality. Thank you.
Wonderful. Thank you so much. Thank you, Mustafa, for that very detailed and very thought-provoking presentation. What really stood out is how you framed desert architecture not as just a stylistic challenge, but as a coordination challenge. I really kind of connected with that aspect. And you showed that sustainability in these kind of hot and arid regions is not just about adding shading devices or improving insulation. It's about aligning the disciplines early in the process. Testing those assumptions, I really like that part, because without the testing, it's a whole different story later on, and preventing conflicts before they become side problems. And I think that's where your strength lies, turning complexity into clarity. Um, all right, so shall we move into the question answer round and maybe unpack some of these ideas a little bit further now?
Yes, please. Yeah, sure. Thank you.
All right, thank you, thank you. So, desert complexity and coordination. Um, you've worked across the UAE and KSA projects in desert developments. Um, where do design conflicts most commonly arise? Is it facade and structure, or is it between MEP and architecture, or sustainability targets versus the budget realities? Because we've heard bits and pieces of all of these over all of the other episodes that we've discussed with a lot of professionals, and these kind of dualities often come up where constraints can be push or pull depending on which gets the priority at the end. So, in your experience, where would you say these design conflicts usually arise? Between whom and who?
Well, I would say that these issues happen and conflicts happen at every decision making point. If we take, for example, a very simple approach for a pattern that is being drawn on the facade as a ventilation, for example, there will be always two different sides of the story. The MAP engineer is looking at the area of the and how it's going to perform for his machinery to work, and they're right about what they are thinking. And on the other side, the architect wants to work on the aesthetic too. They want to design something that looks nice and appealing and matching with the concept that they have shown to the client, which the client already approved. So when you look at this, there will always be conflict between them. How to place it, where to place it, how it's going to look, what is the acoustic performance of this? Is it going to look as nice as expected before? And is it going to perform as expected? Both of them are usually right. Finding the balance between these opposing requirements is the talent and art that teams have to do to work together and to make a proper product. And this happens between all decision making points, between structure and architecture, between MAP and structure. The structure team wants the integrity of the structure. And I remember I posted one comic about this on LinkedIn before, and everyone interacted with it because they found it very relevant. Uh, the MAP engineers want the most space they can get, and the structure team want to maintain the integrity of their structure. So they want to reduce the amount of openings or at least allocate them in specific places that doesn't compromise the structure. So the conflict really happens frequently during the whole design. It's part of the process. I always tell my team members that problems is part of our day-to-day job. We're here to solve problems, and the idea is always to maintain the vision and the priority ahead of all of us. So if there is a change that is required in structure because we have a problem with MAP systems, uh, sometimes this will take priority. Sometimes aesthetic will take priority, depending on the situation and the project.
All right. My next question is about sustainability versus constructability. Um, we often see strong sustainability intent at the concept stage. From your experience, at what point does that intent, start to get a bit compromised or challenged? And how can design managers prevent that through in the outset of the design or through the process of the design?
Well, if we compare sustainability and constructability, in some of the points they will disagree, and in other points they will merge together to be one. So one of the major aspects for any development or any investment that is happening, because all these projects that we're building is actually an investment or an endeavor to create some type of ROI. And if the end users are not buying into this, they do not know what's behind it, they will not back it. The end users in some stages are the construction team, and if the construction team doesn't understand what is there for sustainability for the overall picture, or what is the vision for the overall project, they will start opposing. But once they understand, sometimes they find that it's working in their favor. um, let's take an example of shuttering. If we're using a sustainable material made of recycled wood, that could work for the construction team as well, because in this case the construction team is using a material that is recycled, might be less expensive as well. But if we try to impose strategies that were not discussed before ahead of time, and the team is new to the concept of sustainability, definitely there will be contradictions. And I would say that in most cases, budget or cost is the final say.
Right, right. So I think you've covered many different connected or interconnected aspects that come up through the project. I think that was very nicely put. Um, moving on to my next question, which is about BIM and how we use BIM as a prevention tool. So, you've led BIM transformation initiatives in hot climate projects. How does BIM specifically help to avoid coordination failures or especially where there's a large kind of cost that comes along with that failure? So how can BIM kind of help us safeguard from costly coordination failures during projects?
Well, BIM really works as any tool, as good as the team using it can actually use it. So, imagine this. If I buy a set of brushes and paint and give it to a child, does that make him suddenly a Picasso? It doesn't, right? So the tool that we use, or the processes that we use, is as good as the team using it. If the team using the BIM processes applied properly, and apply it not superficially, just to say that we are BIM compliant to produce LOD 400 or 500. Doesn't matter what bright words you say. If the team working on site are not using it, or the team doing the design are not using it as efficient as it should be, as it was intended to be a single source of truth, then there is no benefit out of it. If they start, for example, showing something in the plans that is not properly coordinated with others, and they do not communicate, does BIM solve the problem? It doesn't. In reality, communication does. So if the architect, for example, wants to change something and want to modify a design in coordination with others, uh, communication is inevitable. BIM makes it easier, it facilitates it, and it makes it easier to avoid mistakes. True, but people need to use it properly to make the most out of it. It's a brilliant tool. I've been using it for a long time. 2008, I started learning Revit, um, and I have lots of certifications about ISO and information management. Um, but what I've seen with teams is that they really need to embrace the benefits and understand it before they can actually get the benefits out of it.
Understood. Absolutely. So I think, yes, I think you put it well. As long as you're using it the right way and as long as you understand the potential of the tool fully, BIM may just become some kind of a superficial add on rather than actually unlocking the project's potential of safeguarding from coordination losses. All right. So, my next question is about fast track pressure. Many GCC projects facing this kind of pressure to do project delivery very quickly. How do you balance speed with proper design validation, especially in extreme climates where performance mistakes kind of really come back and cause issues later on? How does one kind of balance pressure versus the time needed for uh, design to be validated?
All right. So normally with pressure and reduced time, there is always increased risk of mistakes because the team has little time to think, little time to take decisions, and can easily make mistakes that are very costly on the long run. To avoid this, in my opinion, feedback loops needs to be set up early on, and responsibilities and roles has to be set up early on. So one of the tools that we all use is weekly meetings and workshops. Those weekly meetings and workshops serve as a forum for the teams to discuss their ideas, their intentions, how they intend to implement this in the design. And if it doesn't work for another design team member or another consultant who's working on the project, because sometimes we don't have all the consultants in one room. They might be sitting in a totally different country. So these forums of decision making and coordination actually help a lot in taking decisions on the spot. And as frequent as these happen, we reduce the risk of coordination issues under pressure of time and limited resources and uh, pressurized project progress.
Okay, okay. Uh, Thank you for that. Now, moving to my next question, which is about authority and compliance. In desert cities, regulatory approvals can shape design outcomes very often, and it's a kind of tightrope between both these aspects. Um, how early should design managers engage the authorities in order to avoid rework later or to align with what's part of the regulatory approvals, both for medium and large projects?
Okay, so if I understand the question correctly, it's about design management and the engagement of authorities, right?
Yes, the timing with that as well.
Okay, okay. Well, I would say as early as a problem arrives or before it arrives, proactively. So we tend to do this even at pre-concept stages. And the authorities in the GCC in general and in the UAE specifically are very cooperative when it comes to questions and collaboration to make sure that we're moving down the right way. So even if we have simple sketches and a few planning guidelines, we have a discrepancy or confusion, then we tend to immediately request for a meeting to clarify and to get clarity on what we are allowed to and what we are not. If we're aiming specifically for sustainability, for example, uh, is it going to be allowed to do X, Y, and Z? Are we allowed to use these specific materials? Sometimes the material will not be approved even in the UAE, and the authorities will then guide us in the right direction how to get it approved and certified. Maybe this will take 5 6 months to get require certifications. But by that time, we have already developed our design. Our work is more mature enough to accept this material into our project rather than waiting until we complete the whole design and then find out that our assumptions were wrong, this material is not approved, or this method of construction is not even recognized in the country or the city we're building for.
All right, all right. So as soon as possible, as soon as needed, that's the right time. And it's good to know that yes, they are extremely cooperative and they help us to kind of understand how we can integrate project requirements and authority requirements seamlessly. All right. So now moving more into the design aspect, where we can, when we're talking about facade and envelope integration, performance is critical for these regions. Like you also showed us some of the examples and images. Um, what are the most common coordination errors that you see in facade systems that then later impact thermal performance? And of course, I think we know glass is definitely one of those aspects. But what are the other common coordination errors that you see when working with facade systems?
Okay, when working with facade systems in terms of performance, you mean?
Yes, that's right.
Yeah, what I have seen in my experience is people taking unilateral decisions without telling the wider team or without understanding the impact of their decisions on the wider team and other systems working with them. So let's say for example an architect who wants to use an insulated blockwork on his facade in the solid parts of course, and then decides to use a lightweight material, so it's AC rated concrete for um, the assumptions that other team members make based on the loads and based on the performance of this material for MAP and for structure is big. And it's an early decision that needs to be taken as soon as possible. It will affect their work for the rest of the design phase. And then when the architect faces a problem, let's say an aesthetic issue with the client, and the client says, "Okay, we want to fix stone, for example, on the facade," and then he realizes, "Okay, this material is very weak, it cannot take the weight of stone," and suddenly decides to flip the material to something, maybe concrete units, concrete blockwork that still has insulation, but the insulation is not as efficient as AEC. If they do not, at that point, inform other team members because they do not realize the impact they're making on their designs, then we might end up with redesign down the line because the load is different, the performance is different, the heat load is completely different. And the MAP engineers, if they are not aware of these changes, we might end up with failure during operation and testing. So I've seen this in a few projects. Thankfully, it was resolved. But I've seen this while testing something on site that the performance is not the same, and everyone was questioning what happened to our design. Our design was perfect on paper, but perfecting it on paper alone is not.
Right, right, right. So somewhere along the line, I think it's as these changes come in, that's kind of the critical time um, when everyone needs to be updated, aligned. Maybe before implementing change, there can be some feedback from the design team itself to kind of advise or play a role or have a say in that decision where there might be a alternate material that's being missed. Um, or integrate with the design or the redesign aspects. Fantastic. So, my next question is about multidisciplinary leadership. You've chaired multidisciplinary meetings across large teams. And what's the one leadership behavior that most improves the coordination outcome when you're working with large teams?
Well, I would say the first thing that comes to mind is staying calm under pressure. It's very important because teams, when there are changes, tend to sometimes panic, um, because delivery is very soon and there is a change that hasn't been calculated before, or there is a risk that hasn't been calculated. Um, Things like this tend to have a toll on the team performance as well. So I would say staying calm and staying fixed to your vision and understanding your priorities is key as a leader to projects of large teams. Also, communicating frequently is something that is inevitable for any design or project manager or any team leader, because without communication, everything else fades. I would say 70% of the design or project manager work is communication, and the rest is everything else. So this is key: staying calm and communicating properly at the right time.
All right, super. So staying calm and staying in constant contact with your team and with all the communication channels staying open. All right, so now from IFC to site reality, once drawings are issued for construction, what typically goes wrong on site, especially in desert projects, and how can design managers kind of prevent that? Like sometimes things slip through the cracks. Sometimes something changes, like you mentioned, on site. So, what could one do as a design manager to prevent you know any of these issues that happen with link to site? Any advice from your side?
Well, engaging these teams, if possible, in the process helps to avoid all these issues to start with. It's not realistic, and it's not something that everyone can do because you might be handing over the project from one consultant to another, or handing it over to another contractor in a different country, and this increases the risk of misinterpretation and misunderstanding of the documents that they are receiving, because you cannot expect the ones who just received the documents now and are starting to read 500 pages of drawings and more of it in specifications to grasp it immediately. First of all, there might be contradictions, so there will be back and forth communication. And this is why the process is known in the industry like RFIs, inquiries, and queries between the site and the design team is essential. So keeping a buffer of engagement between the design team and the construction team for a while until they absorb the information properly and understand what is required of them, and also to highlight anything that might not be practical, because sometimes we design things that are not really practical when integrated together. And this is why a very important uh, chain or part of a ring in the chain is the construction team. They are going to make this a reality. They will construct it on site. So if they believe something is not practical enough, or some spacing is not uh, actually workable, or a specific material is very hard to achieve or very hard to get during the project time, then sometimes a design change. So communication again is key between the design team and the construction team to make sure that things go as smooth as possible with minimal changes to the overall vision.
Wonderful. I think yes, that really would be the kind of crux of it. When there's overlap, when there's handover, when there's uh, larger, deeper messaging in the communication between these two fundamentally different teams. Yes, I think that's where having that buffer, like you said, would really help. So, all right. Now moving to my last couple of questions. Sustainable communities perspectives. Having worked on large master plans and sustainable developments, how does coordination differ at the master plan scale versus when one is working on an individual building?
Okay. Well, with a master plan and a larger scale project, you you have bigger control, more control over decisions because you can change things like infrastructure, which you're not allowed to when you're doing a single building, for example. Even if it's a high-rise building, it could have the same capacity, same GFA, same amount of people who will live there. But when you're working on a large master plan, you have more control over decisions, especially if you're doing the master planning yourself or you have some leverage to change the decisions at last. So that is one. But with this large control over decisions, there are also complications and larger problems because you might be overstepping some regulations of specific authority requirements for electricity, for example, or for gas connection or firefighting. So you will have bigger risks and bigger challenges, but also more control over the overall output. However, when you're doing a high-rise building, the challenges are not less, they're different. So you have vertical transportation to take care of. You have problems as well with fire and life safety because it's different. If you're doing a large master plan with low-rise buildings, then the challenges for fire and life safety, for example, is completely different from a high-rise tower. And the requirements of civil defense as well differ. So I wouldn't say that one of them is better than the other. They're enjoyable to work with, but they have certain challenges and different characteristics of these two types of projects.
All right, thank you for explaining that very clearly as to how both these are very different. And yes, they don't differ in complexity, but the exact challenges and the precise mechanisms are very different for both of these. So thank you for putting that in perspective. My last and final question is about the future of design management in arid regions. If you had to predict one major shift in how desert region projects will be coordinated over the next decade, what would that be? And is there AI driven modeling, or is there performance simulation integration, or stronger governance structures? What do you see over the next decade, over the next 10 years, as the future of design management in arid regions?
That's a tough question. Thank you. Okay. When we're talking about the future, I think AI and technology is affecting all of our lives. So design managers and the AAC industry should not be an exception to that. So definitely AI is going to be part of it. It is part of it right now. We are actually living that future. But it's a matter of time that people start implementing and integrating this further and further. Um, if we're talking about design management role or coordination between teams, for example, an AI tool or an AI assistant could now check your email, prioritize things for you, send you a message, in the evening to tell you these are the most important emails you have received. You need to respond to this guy faster, or this guy needs an urgent response from you, and you need to set up a meeting for that. So I believe our effort is going to be less on paperwork and day-to-day hassle of checking 500 emails and seeing what is going on there, and it will be more on the actual design process and the creativity required for the design to be accomplished, because we will have these tools that will make it easier for AI, with AI and with the help of BIM as well, to detect issues and detect failures before they happen, or at least reduce the amount of manual work that you need to do detect them. So instead of reviewing things maybe in 3 weeks, you will have less time to review and still accomplish the same results. So I believe we're going to be faster and more efficient in the future.
All right, all right. So hopefully that's how things go and that comes true. So thank you very much. That was a great discussion, Mustafa. Thank you for your openness and your clarity. What I really appreciate is that you've shown us that sustainable desert design isn't just about bold ideas, it's about disciplined coordination, structured leadership, and making sure that the details actually perform under pressure. Now, I'd like to open the floor to our audience. If you have a question about BIM integration, managing design conflicts, fast track delivery in arid regions and hot climates, or coordination challenges in the GCC, this is your moment. So, drop your question in the comments and we'll bring them into the discussion. Just take a look, give them a minute to respond.
Sure, sure, no problem. Could we see these questions on the chat or something? Or?
Yes, so if they do come up on the chat, we'll be able to take a look at them. Otherwise, usually there'll also be questions that come up over the next few weeks as we further promote the webinar after this. So I think we just take a couple of minutes to see if there's any responses, and then we'll take it from there.
Yeah, I see a question here. Do you see AI helping coordination or complicating it?
Yes, so
Well,
that's the
I
first.
think, yeah, I think if AI does something to the industry, it is going to be helping people. It's like computers and using computers. When we used to draft by hand, it was very difficult to make a change, because you need to scratch a page or maybe a few sheets if you want to do a change. Now with computer and using CAD and BIM, it's much faster and easier. I remember back in the days, we used to do projects, and when the MAP engineer comes with a change, small change, of adding one door for the gas hole. Um, that door then has to be tracked down sections, elevations, look for the location of it in the schedules and the specifications required for it of fire rating. So if we imagine that BIM has made our life easier by adding this door once and seeing it in all views and schedules immediately, then I would suppose that AI is only going to amplify our ability to coordinate this across disciplines and maybe even detect issues that this door doesn't have the right fire rating for this specific room as per the room type. So you either have a wrong name for the room, or you have wrong specifications for the door. You need to fix that. And if AI is going to help us in this way, I think it's going to be fast and easy. I hope we reach to one day to see AI helping in the review of coordination as well.
All right. I'll just take a thank you. Just take a quick minute to see if there are any other questions, and then we continue the discussion on the chat after that.
Sure.
Okay, so I think we can go ahead then. So thank you very much, Mustafa, once again for such a grounded and practical session. Today's conversation reminded us that in desert regions, sustainability doesn't succeed because of ambition or vision alone. It succeeds because of coordination, discipline, and leadership across the teams. And turning design conflicts into coordinated solutions is not just a technical skill, it's an entire mindset shift. So, to everyone who joined us live, thank you for being part of this growing community of professionals who care about building responsibly in arid climates. We'll be back next Sunday at 2 p.m. Dubai time with another episode of Designing for the Desert. Until then, stay curious, stay climate conscious, and keep designing with purpose.
Thank you so much. Appreciate it.